VLSos here. This is a video lesson on the unit circle. I've drawn a circle here, and we can call it a unit circle if its center is at the origin and the radius of the circle is 1 unit. The unit circle is a powerful and elegant conceptual tool that bridges algebra with trigonometry. We can imagine any point on this circle, and anywhere this point is on this circle, we can draw a line perpendicular to the horizontal axis, which creates a right triangle. The legs of this right triangle are the coordinates of the point x, y, and the hypotenuse, because this is a unit circle, is the radius of 1. Triangles created in this manner are called reference triangles. And the angle inside of the reference triangle is called the reference angle. I'm going to draw a diagram of the reference triangle. And I'm going to label the hypotenuse 1, the fact that it's a right triangle, and of course the x and y legs of the triangle. The reference angle we'll call theta. This reference triangle is the same geometry with the same labels as the one in the circle. But here I can clearly see that if I take the sine of the reference angle theta, it will equal the ratio opposite over hypotenuse, or y over 1. And we can define sine as y, ignoring the division by 1 in the ratio. And often we like to write the y to the left. We can see that if we take the cosine of theta, it will be the ratio adjacent over hypotenuse, or x over 1. And if we ignore division by 1 because it doesn't change the value of x, we could say the cosine of theta is equal to x. And of course, we like to write x on the left. This angle, if it's inside a reference triangle, is called the reference angle. Reference triangles can be drawn at any point or to any point along the circle, which means that if the point was in the second quadrant, we would drop a perpendicular, and with the radius of the circle, create a reference triangle in the second quadrant. The angle inside the reference triangle in the second quadrant would be the same measure as the reference triangle in the first quadrant if the coordinates of this point were the same x and y values. Except in the second quadrant, the x coordinate is going to be negative. If the coordinates of this point were labeled x, y, then the coordinates of this point that had the same y value would have a negative x. If the point was in the third quadrant, and we're working with the symmetry or the values of x and y, the coordinates in the third quadrant would have the same magnitude x, but it would be negative. And it would have the same magnitude y, but y would be negative as well. The coordinates of the point can have negatives, but they correspond with positive leg values in the triangles. Distances of lines must always be positive, but they correspond with points that can have negative coordinates. And in the fourth quadrant, if we were working with a symmetrical reference triangle with the same magnitude x and the same magnitude y for the legs of the triangle, which are positive distances, then the coordinates of the point would have the same magnitude x and y. X would be positive, like the first quadrant, but y would be negative. All of these triangles have a reference angle that is congruent, or the same measure. So based on observations of symmetry, a reference triangle with the same reference angle exists in each quadrant. Wherever you have a point in the first quadrant, you will be able to find three others. One that has a negative x and positive y value, one that has a negative x and negative y value, and one that has an x and negative y value, creating reference triangles with reference angles that are all the same measure. There's a difference between the angle inside the reference triangle and the angle that is created from the positive horizontal axis as the point rotates around to get to that location. In the second quadrant, the reference angle is inside of the reference triangle, but the angle made by the radius of the circle in the second quadrant is larger and sweeps starting from the positive horizontal axis. We call those angles angles of rotation. It's the angle of rotation that you put into the sine and cosine function to find the height or the y value. In the first quadrant, the angle of rotation is the same as the reference angle. In the second, third, and fourth quadrants, the reference angle is always acute and in the reference triangle, and the angle of rotation is the larger one that comes around to the radius.